Namaskar. In this lecture, we'll continue our previous lecture, which was on canonical transformation. In that lecture, I told you that with the help of Hamilton's principle, we can generate a function f, which is a function of new coordinates qi, old coordinates, which is a function of old coordinates qi, old momentum pi or p, new coordinates qi and new momentum pi, and naturally of time. This we derived with the help of Hamilton's principle, and we showed that if a relation sigma pi dqi minus sigma capital Pi derivative of capital Qi plus k minus h dt, if this expression is exact, then that exactness function was defined as f. If this is exact, then we say that our transformations are canonical. From this expression, we judge that this f is a function of these coordinates. But naturally, you are having transformation equations in which your pi is written as the function of old coordinates, qi is written as the function of old coordinates, and the vice versa is possible, and these equations are 2n in number. So naturally your f finally is a function of 2n plus 1 variables, because you can eliminate 2n variables with the help of these equations, or you can say that 2n variables are depending upon another 2n variables. So finally it is a function of 2n plus 1 variables. Now what these 2n plus 1 variables should be accommodated in f. So we may make different type of combinations. In my previous lecture, I have introduced you about the generating function of type 1. Generating function f1. This is first type of generating function, and this f1 was taken as a function of old coordinate, new coordinate in time, right? These are the position coordinates in generalized coordinate system. And for this f1, we found equations based on this f1, like delta f1 delta qi was pi, delta f1 delta capital Qi was minus of pi, and k minus h is equal to delta f1 delta t. These were the relations which we obtained from this relation of exactness, right? And from here we again found a relation called the Maxwell relation, or the condition for a transformation to be canonical. What is that? If I differentiate it with respect to capital Qi, its right hand side will give delta pi delta Qi is equal to I should write it as, yes, the suffix may be same, delta pi delta Qi is equal to, differentiated with respect to small qi, so the left hand side will be same. This is not the negative symbol. So delta pi small qi. From these two relations I will obtain this type of relation. This is known as Maxwell relation. So if in any situation you are given transformation equations, then you can very well this type of relation to be satisfied if those transformation equations are canonical. So this is one type, one way to show that the equations of transformations are canonical. So suppose you are given Pi as a function of Qi, Pi and time, and Qi, rather capital Pi, and capital Pi as a function of small qi, pi and time. If you are having such type of situation and you can show that this is satisfied, then simply you will say that your transformation equations are canonical. One more relation is here which should be satisfied if your function or the transformation equations are involving time. Then it is delta qi k minus h. Actually, I have differentiated it with respect to qi, and then I'll replace it by pi using this equation. So this is additional condition, or you may find this condition from this also by differentiating it by with respect to capital Qi. So delta capital Qi k minus h is equal to minus pi. डेल्टा पी आई डेल्टा टी होगा ये, डेल्टा पी आई डेल्टा टी, and this will be delta capital Pi delta t. So either this should be satisfied or this should be satisfied if t is involved in your transformation equations or generating function. So this is one way. Now with the help of this generating function f1, we will produce different type of generating functions. I am considering the second type of generating function. Now generating function f2. This is second type of generating function, which is a function of qi, capital Pi and t. This is the standard way of considering these generating functions. If you look at f1, f1 was f1 qi, capital Qi and time. So what is the difference between the two functions? Your qi is same, pi has to be qi has to be changed to pi, and time is also same. So there are certain active variables and passive variables, and you know that this is a relation because qi has to be remain same. So we will not consider this relation, we will consider only this relation. हमें qi को नहीं बदलना है, तो इसको नहीं consider करेंगे, इसको consider करेंगे. This relation is saying that since delta f1 delta capital Qi is equal to minus Pi, and I have to change Qi to Pi, and this type of relation is existing. It simply means you can define a new function f2 in terms of f1. How will we take that function? By Legendre transformation, because this is the condition for the existence of a Legendre transformation. By Legendre transformation, define f2. This f2 will be a function of qi and a changed coordinate pi and time is equal to f1, which is a function of qi, capital Qi and time, and because you are having a negative symbol in this relation, so this will be positive sigma combination of these two pi qi. If you remember the introduction of Hamiltonian with the help of Lagrangian, you know that Lagrangian says that delta L delta pi dot is equal to delta L delta Qi dot was pi, and because of this relation you can find capital H in terms of L as the combination of these two pi qi dot minus L, or you may define it in reverse way, L minus sigma pi qi dot. So similarly, you are having this relation. Here you have taken the combination of these two. Here you will take the combination of these two. If I write it as L minus sigma pi qi dot, then if this relation is with positive symbol, then we take negative, and because our relation is with negative symbol, so in this case the Legendre transformation is defined as Legendre transformation defines or provides a function f2. f2 is defined with the help of f1 in this equation, combination of pi and qi. So from here you can very well find f1 qi in time is f2 small qi pi in time minus summation pi qi. I'll use this relation for 1. In 1, this is now your f1, because we have introduced this f1 from here. So what will be df1? From here df1 is equal to delta f2 delta qi dqi summation for I plus delta f2 delta pi dpi plus delta f2 delta t dt, then minus summation dpi qi minus summation pi dqi. This is the value of df1. We'll replace this value of df1 in relation 1. So 1 implies, first of all you have defined this one, so it is 4 and use this 5. 1 implies, I'll put the value of df1 in this one, sigma pi dqi minus sigma capital Pi dqi plus k minus h dt is equal to this total right hand side, sigma delta f2 delta qi dqi sigma delta f2 pi dpi delta f2 delta t dt minus dpi qi pi capital and then derivative of qi. Now see that these two are cancelled, and then make certain combinations. Sigma of pi, this is dqi, this is also dqi, so minus delta f2 delta qi dqi, then take the combination of this one and this one. You write summation qi dot minus f2 delta pi dpi. Yes, this one and this one, and then this one and this one. So it is k minus h minus delta f2 delta t dt is 0. Now this will be possible only when these coefficients are 0 for every I. So I get pi delta f2 delta qi dot delta f2 delta pi and k minus h is equal to delta f2 delta e. So regarding a new generating function, a new type of generating function, that is f2, I get these equations. So if these equations are satisfied, again you can say that your transformation equation is canonical. Or in other way, if you are having F2, then you can find the transformation equations, you can describe your dynamical system. These two equations again can be combined. If I differentiate this with respect to capital Pi, that means Pi, and this equation with respect to small qi, delta qi dot small qi, then this side will be same and we are having this type of relation. And similarly from here, if I differentiate it with respect to qi, I'll use this one. So it will be delta qi k minus h delta pi delta t. If I differentiate this equation with respect to capital Pi, 3 equation, third part of 6, यानी कि delta capital of Pi k minus h, then it will be delta qi dot delta t. So you may consider either this one or this one, and this is known as Maxwell relation. And it simply shows that if you have your Pi in terms of capital Pi as a function of capital Pi, capital Qi and time, and small qi as a function of capital Pi, this is delta qi dot, just a minute, I have made the combination of, this is not qi dot, this is just qi, ये qi है केवल, this is just qi. So if I have equation qi as a function of qi, pi and time, then with the help of this condition I can show, if this condition is satisfied, I can say that transformation is canonical. ये हमें पता कैसे चलता है कि ये वाली इक्वेशन होनी चाहिए, हमें इस रिलेशन से ही पता चलता है जो हमने बनाया है. मतलब Pi को हम डिफरेंशिएट कर रहे हैं विद रिस्पेक्ट टू कैपिटल Pi, तो जो Pi है उसका एक्सप्रेशन हमारे पास दोनों कैपिटल होने चाहिए, उसके फॉर्म में ही होना चाहिए. इसी तरह से ये जो Qi है, कैपिटल Qi को हम स्मॉल qi के रिस्पेक्ट में कर रहे हैं, तो द कैपिटल Qi शुड बी expressed in terms of all small variables, like, right? Then if you have such type of equations and you are asked, or if you are able to convert your transformation equations in such type of relations, then with the help of this condition, if this Maxwell condition is satisfied, you may say that yes, our transformation is canonical. If time is not involved, then these two equations will give you old Hamiltonian is equal to new Hamiltonian, and in this way you can also frame your new Hamiltonian function. The only difference is that your Hamiltonian function should be depending on the new coordinates, that means on the capital coordinates, so which I explained in example in my previous lecture. Now similarly, we can define one another relation, one another generating function with the help of this relation. So first I write down what will be the third generating function. That generating function will be F3. So I am introducing generating function F3. This F3 is a function of old momentum, new position coordinate and time. So if you compare it by F1 was qi was a function of small qi, capital Qi and time. Now you compare the two. You have to replace this qi to pi. This is same and this is same. So your purpose is to replace qi to pi. It simply means that you should have a relation. You should have an equation, differential equation between these two qi and pi. Now you look at this equation. In this equation, your f1 is differentiated with respect to small q1 and its value is qi and its value is pi. So I'll use this relation. Since delta f1 delta qi is equal to pi, you know that this relation exists. So if this is true, since this is true, this implies, again you can define the Legendre transformation, implies Legendre transformation is applicable. So हम define करेंगे function f3 with the help of f1 and with the combination of these two minus sigma pi qi. So in this way f3 is defined, right? And this f3 will provide you a different type of Maxwell relation in the same way as I have defined in the previous part. Because from here you may define f1, it is f3 plus sigma pi qi. You may find the value of df1 in the same way as I calculated for f2. Here your f3 will be a function of, you have to replace qi by pi, then qi in time. So for that, this f3 will give df3. And what is df3? It is delta f3 delta pi dpi delta f3 delta qi dqi plus summation dpi qi summation pi dqi. So this is the value of df1 in terms of f3. I'll replace these values in the first relation, in this relation, in 1. So put in 1, again make the combinations as I did for f2, and then from that combinations you will get relations like, and get delta f3 delta qi is equal to minus pi delta f3 delta pi is equal to minus qi. These relations will be obtained and the relation for k minus h will be same, right? If you know your f3, if you know your old Hamiltonian, you can find your new Hamiltonian k. From these relations, its number will be 8, this is 8, and you find these relations 9. You can say 9abc. From the two relations, again you will get the Maxwell relation, and that relation says differentiated with respect to small pi delta pi and differentiate this with capital Qi minus delta Qi delta Qi. So this is the Maxwell relation. And from here, if you differentiate this equation with respect to capital Qi, delta Qi k minus h is minus delta pi delta t, or if I differentiate this equation with respect to small pi, delta pi k minus h delta Qi delta t. So these are the conditions for a transformation to be canonical. So this is the easy way. Either you show this type of equations are satisfied, or you show this type of relation, because for these, to show that these equations are satisfied, you will need a generating function. Suppose you are not having a generating function, you are just having the transformation equations, then one way is that first you find the generating function, and if generating function exists, you say yes, it is okay, the transformation is canonical. That means you prove the condition of exactness. The second way is that if your transformation equations are given, then in this case, if you are having pi as a function of small qi, it is as a function of small qi, pi n time, and capital qi, capital small qi as a function of capital QI, capital PI in time. Suppose you are having such type of relations, or you can find such type of relations, and you can you show this type of condition satisfied, then it simply means that your transformation is canonical. So this is with the help of third generating function. In the same way, you can define the fourth generating function. The fourth generating function is F4. Again, there is a standard way to define it as a function of old momentum, new momentum in time. Now again compare it with F1. F1 was a function of QI in time. Now you compare the two. What are the independent variables here, or what are the variables on which F are depending? You see that QI is to be replaced in PI, capital QI is to be replaced by PI, and time is same. So here QI to PI, that simply means we should have a relation connecting the two. QI capital to capital PI in time is same. So we need a relation for this, we need a relation for this. Again, you look at the equations for F1. These are the equations. In these equations, these two are related, these two are related. So I'll use the both the relations. I have the relation, since delta F1 delta QI is PI and delta F1 delta capital QI is minus PI. Now Legendre transformation says that with the help of these equations and with a combination of these variables, you can define a function. Define f, a function say it be f4, and now it is depending upon q को replace करना है pi से, so it is a function of pi. Capital QI is to be replaced by capital PI, so it is a function of PI and time. Right? Define F4 as F4 is equal to F1. Now, this is with, in this relation, you are having PI with positive symbol. So, this relation says minus sigma PI QI. And this is already with negative. So, reverse sign will be reversed. Capital PI QI. This is the introduction of F4 with the help of F1. Now again you find F1, F4 plus summation PI QI minus summation capital PI QI. Find DF1. DF1 is delta F4 delta PI DPI plus delta F4 delta capital PI DPI delta F4 delta T plus derivative of small pi QI, derivative of pi as such, derivative of QI minus summation derivative of capital PI QI as such, summation PI derivative of QI. This is the value of DF1. Again, substitute the value of DF1 in this relation 1, make the combinations and compare. You will get put in 1, and since you have introduced these equations are equation 10, this relation is 11. Now put in 1, this 12, and get the relations for F4. For F4 you will get delta F4 delta Pi is Qi, and delta F4 delta capital Pi is Qi. These will be the relations. Again, with the help of these two, you may get Maxwell relation. This gives delta Qi delta capital Pi is delta capital Qi, derivative of Qi with respect to Pi. This is the Maxwell relation. And this shows if you are having transformation equations, that means Qi in terms of capital Q, capital P and time, and if you have capital Q in terms of small q, Qi, Pi and time, then with the help of these two equations, if this relation is satisfied, you will say that your transformation is canonical. So in this way we get I assign it number 13. So if you look at the relations, this is one relation, this is one relation which is the Maxwell relation, and this is one set of equation, right, for F1. Here you have to talk about F1, here you have not to talk about F1. You may simply have equations of this type and you may get the relation. Second set is this one or these relations for F2. The third one is this relation or these set of equations for F3, and the fourth one is this one or these sets of equations. If either of these relations is satisfied, depending upon that in what form your transformation equations are given or you can solve them, you may find that your your transformation equations are canonical. You may find the generating function. You may describe your dynamical system. So this is all about 4 types of generating functions. They are known as generating functions because they are generating the transformation equations of our choice. We are requiring the equations or the coordinates to be transformed in such a way that your problem becomes simple, your coordinates may become cyclic. So these are the 4 ways, or you can say these are the 4 types of generating functions. Now it depends on your question, on your dynamical system. If your dynamical system is described in such a way that your generating function is of type F1, you use those equations. If your generating function is of type F2, F3 or F4, accordingly you may use the relations. But you are free to choose any of the Maxwell relation depending upon the form of equations. Thank you.